Hi, in some previous videos, which I'll link in down below at the end if you haven't seen them, we've taken a look at these remarkable 3-cent microcontrollers from a Taiwanese, not Chinese company called Padauk, and how we can actually program them with the supplied programmer and also emulate them as well. So this particular programmer and emulator is, whilst it's not that expensive, it is actually quite difficult to actually get a hold of one of these. You've got to buy it from like some weird like Asian suppliers you've almost certainly never dealt with before. It's not that simple. So a bunch of users on the EEVblog forum have, I can't list them all, sorry, but anyway, there's been a whole bunch of threads like over the last year on the EEVblog forum. What they've done is actually not only reverse engineered the Padauk microcontrollers, but they've also released it's called Free PDK, and it's on the GitHubs here, which I'll link in down below. And what they've got is open source programmer hardware, open source programmer software, and they've added support for the SDCC or small device C compiler to support most of the Padauk microcontrollers, because they do actually have a lot of micros. If you go to their website, you know, they've got different ones with 12-bit ADCs and 8-bit ADCs, ones without them and stuff like that. And they do actually start, if you go over to LCSC here, who's one of the official suppliers from, they do actually start from like under 3 cents. In fact, like 2.7. I've sort of Yankee cents. I've rounded it up to 3 cents. Remarkable that you can get a 3-cent microcontroller, and yes, you can afford to buy like tubes of them like this because they're so cheap. Now these are actually one-time programmable microcontrollers, these cheap ones. I do believe like they have 1 or 2 models that do actually have flash memory, but the whole point of this is that they're 3 cents, or they start from 3 cents. A more capable one with, you know, that might have some hardware UARTs and like ADCs and things like that might be in the order of 10 cents, but still these are like 3, 4, 5 times cheaper than your other mainstream brand microcontrollers. And the problem with the Padauk microcontrollers, not only the kind of difficult to get programmer / emulator for it, is also the C compiler that they had available for it. It's I believe it's called MiniC, and it's not really properly ANSI C compatible. It's sort of Padauk's mini C, quasi C, whatever you want to call it. So, you know, for those used to a programming in C, it's not really the best environment. But the fantastic thing about this is that quite a few smart cookies have reverse engineered this, and actually there is now full open source hardware and software for programming, emulating as well. There's like they've got emulators which you can put in VHDL and all sorts of stuff, and there's all sorts of examples. So I thought we'd actually build up the open source programmer hardware and install the open source programmer software over a series of videos, because I've already shot the videos, and trust me, there's a lot of traps for young players in there, and we come agatsa. So it's sort of like, you know, play along with Dave as I attempt to build up, because I've already built one, open source hardware and program these Padauk microcontrollers with proper open source, you know, like ANSI C compatible compilers. This is absolutely fantastic. So hats off to everyone who's actually worked on this, and now it's completely opened up these remarkably cheap microcontrollers. So it's gotten to a point now where, you know, you might be able to feel confident about using these ridiculously cheap 3-cent microcontrollers in a commercial product. And that's the whole idea behind this, is that they're remarkably low cost, but, you know, it gave you the bit of heebie-jeebies before, but now with full open source support, let's see what we can do. So rather than just shoot one concise video, what I thought I'd do is do sort of like a play along with Dave as I try and not only build the hardware, but also install the software and figure out how it all works. And then, you know, so you're sort of sitting over my shoulder as I'm doing this over a series of 5 videos, all linked in to a playlist somewhere up here, where we actually go through step by step. So unfortunately, if you're after a really short, concise tutorial video on how to get these Padauk micros up and running, this video series might not be for you. It's like going through all the steps, warts and all, problems, solving things along the way. But hopefully that's more fun. So anyway, this particular video I thought would be about actually, it could really apply. It's not really for the Padauk one here. It's if you happen to see a project and it's available on, say, GitHub, like an open source project, but nobody sells a kit or the finished product, and you want to build it. How do you go about it? Well, in this video, we're going to, part one, we're actually going to take a look at actually looking at the programmer hardware down here, going in there and looking at how to order all the parts, how to order the PCBs, and that sort of jazz. Let's get to it. Right, so here we are. We're in the GitHub of our project that we want to manufacture, and we go down here, EZEDA Programmer Hardware. So we click on that, and we have a look at what's available. Maybe the README has something. Probably want to do that. But this is the hardware that we want to build down here. There you go. Now they actually come on a panel of 4 like this, but really I only wanted to order 1. So we'll go through the process of doing that. So up here, it looks like we have our schematic, and we can check that. That's available as a PDF. Very nice. I always appreciate when people produce the PDF. Nice single sheet. There you go. It's laid out quite well. It's got all the stuff you need. So beauty. You want to print that one out. Have it on your desk. So you have easy reference. And here we go. We've got our BOM file down in here. We've got an assembled JPEG. Whoop, assembled JPEG. We've seen that before. And our BOM for LCSC, which is where I'm going to actually order the parts from. Now, they didn't originally have this. I actually requested way back that I was having trouble importing their BOM, in their original BOM, their CSV BOM here, into LCSC. So it was really nice of them to actually add this to the Git. Because if you don't know, whether it's Mouser, DigiKey, or LCSC, or any of the other component suppliers, most of them will have a, look, this one's, it's right up the top here. It's got a BOM tool where you can import your BOM or bill of materials of all your parts. So rather than having to like actually print out, like you can just print it out, okay? The traditional way to do this, here it is, right? So they've got the manufacturer's part number. So you can actually go here like this, and let's say we wanted this ST micro like this. You could actually just go over here to like LCSC or DigiKey or anyone like that, and you can search for that. There it is, okay? And they've only got 1. In some cases, there might be more variants. So if we go over to DigiKey, for example, and we search for that there. Oh no, it's pretty, that part number is pretty specific. I think that's going to include the package. Okay, so what these variants are here, you can tell this is the specific part number like this, but this one is the same part number but has TR on the end. And what TR stands for is tape and reel. So if you're ordering a whole reel of them, then i.e. you're going to get your product machine assembled, you're going to get it pick and place assembled, then you want your chips on a reel. You don't want to just like loose in a bag or whatever, because your assembler is not going to be happy with you, and they're going to charge you a fortune to actually hand assemble those things on. So if we actually go inside there, we can see that these are available on available in a tray like this. Once again, pick and place machines can actually pick them from a tray, but generally I found that most assemblers would prefer tape and reel parts than trays. So only get the trays if you absolutely have to, or cut tape, which is if you just want to buy 5 of them because you're going to build 5 boards yourself, you got to hand assemble them. You just get the cut tape, so they just take cut a bit off the tape, or you can get digi reels, which is order as many as you want and they will re-reel, put them on a specific reel for you. They'll get their re-reeling machine out, they'll take the cut tape and they'll put it on a reel, and they charge like $8. I think there's an $8 charge or something like that for the digi reel. Anyway, so you can do that, and then you can repeat ad nauseum. And the good thing about this BOM is that it does actually have the part numbers. A lot of like projects out there, GitHub or otherwise, they won't bother with the manufacturer's part number. They'll just go, oh, it's a 47 microfarad cap. Why should I bother with the part number? But they've actually given you specific part numbers. But for things like these, like a 47 microfarad 1206 capacitor, for example, the part number does not matter. It is not critical at all. As long as it's the same value and the same footprint, the dielectric material, if it's XR7 or it's Wi-Fi or whatever it is, it's not going to matter a rat's ass, basically, unless you have some really specific niche application, in which case they really will specify. And they should put like a little asterisk on the schematic and annotate that saying it must be this part because reason. You know, so that's a little tip if you're designing products, annotate your schematics with useful information like that. Anyway, so you can go, the point is you can actually go down and, you know, copy all these one by one into your DigiKeys or your mouses or your LCSCs or whatever, and then you add them to your shopping cart up. You choose how many you want, you add them to your shopping cart, and it's tiresome. So they have these BOM tools which you can actually import bill of materials. And unfortunately, oops, they're out of stock of that microcontroller. Wah, 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 wah. Good thing I don't have to order them now because I'm shooting this video quite some time after I've already received these things. I'm sort of back shooting. Is that a term? Is now. And what you can do is you can just drag the XLS file in here, and often they will provide you a template of what format all the cells and things must be in. So if you have a look over here, like they usually have a format that these things have to be formatted into. So you can either select a file or just drag it in. And yes, I did this quite some time back. I've had my parts sitting around for quite some time. Anyway, so I ordered 29 parts. And of course, if you don't know how to use, if you don't actually use Git, you can actually just download the zip here for the entire project. And this is what you do before you start. You just download the whole blinking lot. All right, so let me show you what happens if you just import the incorrect, just the regular CSV. Import the CSV like this, boom. And here it is. Okay, it's imported it, but you have to like manually select like what things are what, and it does work, and it does actually have the supplier is LCSC for all of these in their original BOM, and it does have the specific supplier part number, LCSC part number. So, and then you've got to go over here. No, you just ignore that. It's just a value. And then we've got quantity here, manufacturer part number, manufacturer. That'd be our package. Just put description for that. And then that, we don't really need it. We can't just ignore that field. So I don't know, we'll just put customer part number or whatever. So we've now, this is if we want to import like just a CSV into this tool. The BOM is in process, boom. And now we have our entire BOM imported from the CSV. But of course we could have just downloaded the specific BOM, the BOM LCSC in LCSC format specifically in. But you see, it wasn't that hard to actually do this. I think when I did it, there was some issue which made me have to do the get them to do the LCSC version. It wasn't this easy if I remember right. Anyway, here's all the parts, and and it's got the quantity over here, the purchase quantities. Can I make maybe I'll make myself a bit smaller. Here you go. So we got the purchase quantities like this, and you might need 2, but it says you need a minimum of 10 because they just won't sell your onesies, twosies at 2 cent, right? So, and it tells you they come on cut tape and things like that. So you'll notice that, it tells you some are out of stock and things like that, which is really great. And it requests multiple of 100 because this is like a 20 ohm resistor. They're not going to cut off like 3 20 ohm resistors. So you've got to order 100. But the good thing about ordering, because they're so cheap, and the good thing about the minimum order quantities like this is you'll be left with leftover stock, and you can use those to stock up your parts bin, which is absolutely fantastic. So yeah, minimum of 20 of these little pin headers, for example. You only need 1. So bingo, you've now got a whole bunch of pin headers which can go in your parts drawer. Fantastic. So anyway, after you've done all that, you'll notice that they're all ticked here, and you can add estimated total $7.90 once you've done all that. But anyway, so you can add to cart times 1, and bingo, we now have 28 items in our shopping cart, and we can just check out. And I think it has actually added minimum quantities. I think it has changed them all to minimum quantities like this. So this is the minimum that you're going to get away with like this. So what's our total? So there's a few ones which request a quote and things like that. So you might have to go for another 6.8 microhenry inductor. It's not going to matter that much about the specs for that. It's just for a DC, a fairly jelly bean DC to DC converter they need in here for the programming voltage. So not really a huge deal. Just pretty much choose any sort of similar footprint, 6.8 microhenry, and you'll be right. No wuckers. And it's not going to give us a subtotal. But anyway, there you go. That's loading into the shopping cart. And you can whack some extra product. Always whack some extra products on there, including some micros to actually play around with. Beauty. So anyway, yep, I've already ordered those before, so I'm not going to order those again. So that is all the shopping cart experience. So now what we want to do is order the blank PCBs, of course. So what we're going to do here is go into our PCB, and what have we got? Gerber's, no silk. Here you go. And this is another one where I had to get them to actually add a specific single PCB in there, because the files were only available on EZEDA. That's right. I think they had the EZEDA project up here. So I don't use the EZEDA, but if you do, there you go. You might be able to load in your project. But of course, like, it could be available in KiCad format or Eagle or Altium or whatever format that they happen to use in that particular. So they've got some adapter PCBs if you actually want the little adapters. But these little adapters here, I actually just bought a bunch of these. That actually came with my EEPROM programmer I don't have here. But anyway, yeah, I bought these for my TL866 EEPROM programmer. So I already had a bunch of these little SO8 little adapter things, so I didn't need to manufacture those. But if you do, you might have to get those PCBs manufactured as well. So let's go into PCB here. So in here, they've got the zip file for the Gerbers, and also a subdirectory for the Gerbers with no silk, means no overlay, no silk screen overlay, as these boards will actually come, and I'll talk about that in the next video. But it looks like it's got everything here. It's got the board outline layer. That'll be the mechanical outline layer. It's got the bottom copper layer. It's got the bottom solder mask layer. It's got the through hole. That's what PTH stands for. The through hole drill stuff. It's got the top layer copper. It's got the top paste mask layer, which we don't need because we're not getting a paste mask stencil made. But if you do, if you want to get it, or if your PCB supplier supplies a free, like stainless steel or even a Mylar paste mask, and you like using solder paste and stuff like that, then you might want to supply that. That might have to be supplied separately, but we're not going to worry about that. And the top solder mask layer. As it says in the title, there is no silkscreen layer. But all of those files should come in the silk here. Now, there is that panelized version we saw before that had 4 boards. I don't know why you'd want to build up 4 of these programmers. Usually you only want 1. I would prefer to do that. And then if you get that panel made, then if you want to be able to snap them off easily, you've got to have V-scoring. And if you get in one of the cheap prototype PCB services, you can't just do that. You can't just go, okay, I want my board, but it's only this big, but I also want 4 V scoring grooves in there so I can snap them off. It doesn't work like that, because V scoring has to be done on an entire panel basis. They can't just go in selectively like V score your individual board. It has to go through. I've done a video on this showing you machine. They put the whole panel in like that. So you've got to share these panels. This is why they're so cheap. You share the panels with 100 other people. There's 100 other boards on the same panel that's being manufactured, and if you pain in the ass, you want your little V score for the panel, they're going to say no. We can manufacture the panel for you, but it's going to cost you a lot more because it has to go through its own separate process. So yeah, don't do that. You can order 4 of them, but just say I don't want silkscreen, and then but then they get all confused. But then they come back to you with questions. Oh, do you really want V scoring? If you do, and like, how do you want us to route it out? But they're too close to add routing paths and stuff like. Oh, it's just no. Get your individual one-off boards made. So there we go. That just has all the same stuff. We just want our one board. So we can upload that So let's just go into JLC PCB, no recommendation. I just happen to use them and this is where I got my ones from. You may want to use your favorite PCB supplier, doesn't matter. A rat's really who you use to get these. So anyway, 2 layers, 1.6 millimeters. Anyway, let's just go into the quote tool and then we can dick around with it in there. Here you go. Oh, and we could have used any Gerber Viewer to import and like look at those Gerber files, but JLC have a Gerber Viewer as well. A lot of the online ones have Gerber Viewers, so we'll be able to see what it looks like before we get it made. You shouldn't have to make any tweaks yourself, but if you do, of course, you're probably better off doing that on the original PCB file, which in this case I think is EZEDA. Okay, this is 63 by 22 millimeters. And if you didn't have one to hand, you would have had to load that up in Gerber program and actually get your measurements there. 1.6 millimeters red, because red goes faster, trust me. Surface finish, we don't want any of the ENIG, which is immersion nickel gold. We don't want that fancy gold rubbish. We'll just go with Hassel, which is hot air surface leveling, or with lead. No, we'll just go to lead free. Oh, change red. There are very few people choose below combination. Okay. Oh, this is new. I've never seen this message before. Wow. There you go. Extra $16 for the special processor. This probably has to do with all their backlog and stuff like that. The recent shutdowns and everything. But I got mine made red. So, yeah. Sorry. Yeah, I never got that message before. So, anyway, change red to green. Okay. We'll have green. Thank you very much. It never used to cost any difference. So 1 ounce copper is fine because there's no heavy currents on this thing. Gold fingers, no. Standard FR4. Panel, no, we do not want a panel. Flying test, don't bother. For a board like this, I wouldn't even bother to flying probe test. I just don't like wasting their time when it's like a nothing burger. But, you know, if you're like, does it come for free? I think it comes, yeah, I think flying probe testing comes for free. It's like, you know, they might do it anyway because they're manufacturing a whole panel. Castellated holes, no, they're the holes on the side of the board. No, we don't want those. Different designs, we've only got one design. Remove order number, yes. Yes, because otherwise they will put your order number on the board and that's really, do they charge you extra for that? They charge you extra to remove the order number. All right, we'll leave it on there. Because this is not, you know, a front panel board. It's not, you know, an important thing. So, yeah, they'll put their own custom order number on there. And the reason that they're charging you more for that is because, A, it's a manual process that they have to manually do it. But then also when they get the big panel, huge giant panel like this manufactured, then they need an individual order number on there so that they can track who that, but when they snap it out of the panel, they know who that's going to. So they just have to manually check, and that's an extra process. It costs extra labor. So they're going to charge you an extra, what, $1 or something for that, $1.50 or something. Anyway, we don't care about any advanced options. 4-wire Kelvin test, no. Paper between PCBs, no. We don't care about any of that. Free SMT assembly. Wow, really? Oh, there's a coupon for free SMT assembly. Jeez. Anyway, no, we don't want that because we're going to assemble it ourselves. That's the whole point. Anyway, stencil all together with the PCB. And, you know, and yeah, look, if you want a stencil framework, no, we don't want fancy framework. Electro-polishing, no fiducial, all that. No, we don't want a stencil. We just want our boards. Thank you very much, because we're going to hand solder all these. Anyway, let's add our Gerber file, okay? And you can actually just specify the zip file. So I will, off screen here, I'll specify the zip file and it just processes all the Gerber files. And we shouldn't have any problems. It's pretty plain vanilla stuff that we're importing here. Come on, you can do it. You can do it. You can do it. Is it done yet? It's stuck on 96%. What's going on? Your files have been successfully uploaded, as it may take a few minutes to generate preview. It never used to take a few minutes. So yeah, they've changed things since I last used it. Anyway, in the meantime, I thought I'd just find a random online Gerber Viewer. Here we go, online Gerber Viewer. New viewer, I don't know. Let's have a go. Start viewer. Okay. Oh, we gotta log in. Bugger that. Online Gerber Viewer. Looks like PCB have one. PCB Go-Go, Gerber Viewer. EZEDA have one. Like, yeah, there's lots of online Gerber Viewers these days. This one didn't work. Don't like that one. Upload. Let's have a look. Let's actually do a little mini shootout of Gerber Viewers, shall we? Online Gerber Viewers. Here we go. Pass in. Oh, that was quick. Upload. Oh, PCB Go. That looks identical. No? No, it's not. Could be. Let me. Yeah, that's. I think that's. Is that the same? Please go to JLC. Oh, okay. To view the Gerber. Did JLC actually have an online Gerber Viewer? No, they didn't. No, they don't have a Gerber Viewer. It's only as part of the ordering system. Anyway, here you go. The PCB Way one, free PDK. There you go. We just imported that. That looks fantastic, right? Here's the different layers. There you go. You can turn them off and on. Oh, wow, I like that. That looks really good. Yep. Top of the board looks like they're all lined up. You know, nobody goofed the offsets or anything like that. Everything looks fine. There's no silk screen. As I said, this text here is not silk screen. That's actually embedded because, look, you can see the gold color. It's not done as like white or, you know, some other silk screen color. That's actually copper on the board. And that will, in our case, we're not ordering a gold flash PCB, immersion gold PCB. So it won't come, it'll come up silver instead of gold. It'll get, you know, that silvery lead-free rubbish color. And same with the text over here. But anyway, that's a good Gerber Viewer. I like that. Oh yeah, nice, nice. Anyway, you can see the solder mask slither there. The expansion is quite large. I think my board had more slither than. Have they automatically expanded that? You can see the line going between the. I mean, that won't be manufacturable, right? I guarantee you, if they tried to manufacture, I don't know, that looks like a couple of thou, a couple of mil, a couple of thousandths of an inch thickness. That's just not going to get manufactured. So if they tried to do that, because some manufacturers, I've done a video on this in the past, they will actually touch your Gerbers. I used to have a t-shirt, don't touch my Gerbers. And they will actually do the solder mask expansion around your pads, and I hate that. Hate that. Stop it. Anyway, the ones I got, I'm pretty sure. And as you'll see in my second video, the assembly video, the board I got, you can't see it here, but you see it in the second video, is that from JLC, is that they didn't do the solder mask expansion. Anyway, I believe we are good. Our file's been uploaded. Didn't take that long. It's been saved to your file manager. And here it is. There we go. Can we go in and have a look at that? So we click on our Gerber Viewer there. It's got analysis. Minimum trace width is greater than 10 mil. Minimum trace spacing is greater than 10 mil. Minimum drill size. So we're looking sweet to get it manufactured. There we go. You can zoom in. Look, this has done the same thing. This Gerber Viewer, this is curious. It's done the same thing as what PCB Wade showed. But as you'll see in the second video, our solder mask doesn't look like that. So it's much thicker, as you'll see. So I don't know what the deal is there. I don't know if they've changed something since I got my boards made or what, but that's interesting. Anyway, all we care about with the Gerber Viewer here is that everything looks right. It looks like the final board, which they show you over here. If you go over here, they will actually show you, there you go. That's what it looks like. And that it looks exactly like that on the preview. So what you see is what you get pretty much these days. So I'm happy with that. So we should just be able to like save that to our shopping cart. Anyway, look at this. I mean, crazy, right? Engineering fee, $4. I mean, remove order number, $1.50. It's still got the remove order under there. Remove order, no. I mean, like under $10. Like, and it's like, it's $18, $19 for DHL Express Priority Australia. Even that's cheap because, you know, it's tiny. It weighs absolutely nothing. But DHL Express Priority, oh boy. Anyway, when I was a boy, so we got 5, so we get 5 boards for our $10. Absolutely incredible. Plus delivery is more expensive. Anyway, it's nuts. So that's what you have to go through to get your board manufactured. Now, of course, we could do, let me show you the other one. Where was the good online viewer that we have? I really like this one. Let me choose if you got the panel version of it. Let's upload the panel whoa. Yeah, didn't like that. There you go. Yeah, this is the issue that I had, is that the panelized version that they had was not actually the full panelized Gerber. It was the one board like this, and they didn't actually copy it on the Gerbers. Like, so like the data is physically not in the Gerber file for these other boards. It's supposed to be 1, 2, 3, 4, but there's only one board there. So that hasn't been rendered from EZEDA or whatever package they use to do this in. It just hasn't been done. They haven't produced those Gerbers right. So that's useless. So you don't want to get that manufactured. This is why don't touch manufacturing panels like this if you're just trying to get, if you're just making your one-off board. Just, it's more hassle than it's worth. And as I said, even if this was imported properly and did actually copy over, then you would still have the issue of them questioning, oh, this looks like a panel, because they're experts at doing this. They do it 100 times a day. And they'll go, oh, this looks like a panel. You want us to make a panel. Oh, do you want V-scoring, or do you want routing in here? And I believe this one, it didn't have enough room for the routing in there. So it's got to be V-scored and things like that. And then they won't do that on the prototype panel, as I said. And it's just a whole end of problems. So just don't do it. Just don't muck around with panels. So hopefully the GitHub project that you will have individual files, and most of them will. I don't know why they bothered like having a panel like this. And the original GitHub, that's all they had, is they had the panels for this. And you can see the V-scoring in there, actually. There you go. You can see how that's actually V-scored all the way along there. So these big cutting wheels come down and go, and you can't do that on a panel that you share with other people. And just for kicks, because they have an EZEDA project, I'm actually going to, I thought it was a browser-based thing. It's an online PCB tool, but you've got to download it. So anyway, and it's all part of LCSC. They're the ones who do EZEDA, and it's all integrated. So in theory, you should be able to use LCSC for everything here, like designing the board, importing the bill of materials. They sell you the parts, and they'll even assemble it for you. And so, if somebody wanted, there could be a complete turnkey solution here for using LCSC to get these manufactured. So if somebody wanted to go, right, I'd love to be able to sell these boards or whatever. So whether that's for profit or not for profit, whether you wanted to make these boards available so people didn't have to build them up. If you wanted to promote these Padauk micros and just so people just buy the ready-made thing, the ready-made programmer board here, instead of, and the firmware's already programmed, instead of dicking around with multiple videos, as you're going to see in this series of how much, just little traps involved in not only hand building the board, it takes, hours to build it up. Then the microcontroller's blank, so you've got to program that using DFU, and there's a few traps for young players in setting that thing up, as you'll see in the coming videos and stuff like that. Anyway, I might see, just for kicks, I might just download that and see if it loads in. See if the project loads in. There's nothing like padding out a video. Next. Okay, it's installing. Run mode setting. I guess this is a little review of EZEDA, is it? Teamwork. Projects are stored on cloud server. Work anywhere. Projects are stored on your own computer. Teamwork is that. And full offline, I think, you probably have to pay for that because this is a free thing. Anyway, apply. Yeah, whatever. Happy to put it on my C drive. We're in like Flynn. Skip. User management area. We don't care. There you go. So here's all the parts, and these are all linked to their supply part numbers as well. So I presume that like all of these will have like, LCSC parts. Here you go. And JLC PCB. No, they just link you over to the page. But anyway, libraries. Here you go. EZEDA types. JLC PCB assembled. Whoa. Okay. So yeah, these are all the parts that presumably you can get as part of their assembly service. So if you were looking for a turnkey solution for this, this is where you might want to modify. If you went, right, I love these little Padauk micros, and I'd love to actually sell these little things made up, and maybe in a nice little case you might customize it or something like that, and you program the micro for people so that you can make a little midnight engineering business selling these little Padauk microcontroller boards. If you wanted to do that, if you wanted to, and you wanted a turnkey solution, then you might want to modify the project and the bill of materials to use like specific parts, like these caps, for example, that they actually, here we go, capacitor arrays, aluminum electrodes, don't have any, but multi-layer ceramic capacitors. These are all the ones that they will, look, we were talking about the 1206 one before. I think we need like a 47 microfarad or something like that. We probably don't need 47 microfarad. Like it doesn't matter. So you might go, oh, let's just use a 4.7 microfarad. So there it is. So you might want to, anyway, hours and hours and hours involved in a tutorial of how to like modify a project like that. But anyway, what I want to do is I want to open a project. Open. Here we go. And they can open Altium files, Eagle files, and KiCad files as well. That's nice. Anyway, we do have the file in here. What? Where is it? Oh, I'm in the wrong subdirectory. Right. EZEDA project. Here we go. Oh, it's a zip. I don't think I can open a zip. Yeah, no. All right, I just unzipped that. So let's do that again. One more time for the dummies. There you go. README, PCB, JSON, and schematic. JSON files. All right. I assume we can open both at once, can we? You betcha. Yep, it's loading in. There you go. There you go. Beauty. All right. Space or R to rotate, no wuckers. So there's our schematic. So if you wanted to modify something, so as I said, like let's just go in and say, as we said before, oh no, it wasn't. It was 4.7 mic, it wasn't 47 mic. It was 4.7. But just say we wanted to change. Can we? No, you can't. You can't double click. Here's the attributes over here. Here you go. Supplier, LCSC. Did you keep mouse element for it? Wow, that's nice. Okay. Supplier part number. Wow, excellent. So if you didn't have that sort of stuff in there, if you had a project that you wanted to get turnkey manufactured from, say, LCSC, or you can use others, but if you want to get it manufactured from them and they had the schematic file, then you could import like a KiCad schematic file. You could import that, and then you could go through and you'd have to do each one. You'd have to do each part. You'd have to go and then like find the specific part number and do all that sort of stuff. But anyway, can we view datasheet for that? Really? Yep, there you go. It takes you over to here and takes you over to that's nice. EZEDA. Actually, it's pretty comprehensive, must say. I like that aspect of it. Anyway, here's our PCB. Ta-da! So if you wanted to make a few changes on here, you most certainly could. Oh, there you go. We've got live by default. We've got live net view, net highlighting, both and on both layers, because we're presumably not in single layer mode if it's got that. Yeah, because sometimes you just want to work on a single layer. You don't want the other. You want to view the other layers. You want them in the background there, but you don't want to be. You don't want it to highlight this bloody one that's on the bottom layer there, because it's you don't want to dick around with that. Anyway, so EZEDA, I've heard good things about it. If you want a turnkey solution and all their parts are in their inventory and stuff like that for simple, you're not going to do hugely complex projects with it. I wouldn't recommend it. I'd recommend going to KiCad or Altium or something like that. If you're really serious about doing high level designs and things like that. I'm sure you could. Doing an EZEDA, I don't know. Anyway, this is not going to be a CAD tool shootout, but there you go. It does load in. So that's pretty cool. So we could have modified that. And then how do we generate our Gerbers? I presume we can just go generate PCB Gerbers. There you go. PCB fabrication files, Gerbers. So if we did make our modifications, please save your file. We could just go in there, generate the Gerbers, and then upload them the same as what we saw before. So there you go. That is just nice that they make the project file like that available in the GitHubs. So yeah, EZEDA, neat. Once again, I don't know why they didn't do the silk screen on the thing, because silk screen comes for free these days. You get them on these panels and whatnot. And as you'll see in the assembly video of this board, like the silk screen probably would have saved some time, would have helped, but it doesn't matter in the end. Anyway, so there you have it. That's a little bumbling look through getting a project, a PCB and parts ordered from a GitHub project like this, and it can be any project, doesn't have to be this particular one, but this is what this series is about, is building up this board. So anyway, I have another 4 videos. The next one is building up this board. Then the video after that is programming the blank Atmel micro on here, not using an Atmel programmer, but actually using the USB port, using the USB serial bootloader that's automatically included, that's burnt into the silicon of the Atmel microcontroller. It's called DFU, or device firmware update mode. So, and we had a few issues with that, and then we get into the SDCC, the small device C compiler, that now supports these Padauk microcontrollers. And then I've got another one testing. Anyway, there's 5 videos, and we had like a weird hardware issue in the last video. So you want to, it's spooky action at a distance. You'll want to see that one. So there you go. I hope you like this. If you did like this, if you do like this series and this video, please give it a big thumbs up, but leave it in the comments down below. As I said in I think my final video of this series, is that like this is just follow along with Dave as Dave goes through and installs these things for the first time, and hopefully the whole idea behind that is that you learn a lot of stuff and learn about the hurdles on the way. Because yes, I could just produce a 10-20 minute polished video where nothing goes wrong and showing you how to actually in 10 easy steps how to get this thing up and running and programming apart. But it's good learning process to see the fails along the way, and hopefully that's what this series is going to do. So there you go, 5 video series all linked somewhere. Yeah, you know what to do. Catch you next time.